Alright, we're on the third video for the exam 2 review here. It says use the graph of f of x on the right to find the following. So domain of f, if we go, well, first of all, there's a point there, and notice this goes forever to the right. So from left to right, we're going from -4, the x value at the leftmost point. Notice there is no rightmost point, so we would say -4 to infinity. The range, we want to go from the lowest to the highest point and look at y values. So here the lowest point has a y value -2. The highest point has a y value of 4. So the range is -2 to 4. And so notice with domain and range, it is possible to have normally the endpoints are included, that's why we're using brackets, whereas with increasing, decreasing, and constant we're always going to use open intervals, again of x values. So I'm going to go ahead and again split up this graph. Notice going from left to right, we start at that leftmost point, and you can see we're decreasing on that first interval where x goes from -4 to -1 here. Whoops, I'm sorry, let me finish this up. So we're increasing here, and we're constant here. So we know going from left to right, if we're going down, we're decreasing. If the graph's going up from left to right, it's increasing. If it's flat, then it's constant on an interval. So now on the left here, notice from -4 until x is -1, that's where this graph is decreasing. So again, this is an interval of x values, -4 to -1. And then after that point, we're right here right now. Now the function starts increasing when x goes from -1 to 2 here. And then finally, once we get to 2, from now on the constant's going to be constant. And so from 2 to infinity, the function is constant, or the graph is constant. So we need to find f of 2. So when x is 2, that's my input. Notice that's this point. Whoops, hold on a second. Yeah, that's this point here. Notice that's the point on the graph that has an x value of 2. And the height of the graph there is going to be the y value, which is 1. So f of 2 equals 1. Goodness, I thought I put in my stops here, but I guess I didn't. Hold on just a second here. Alright, so we got to find f of -4 next. Well, when x is -4, that's this point right here. The height of the graph is the y value there, 4. So f of -4 is 4. Now for h, it says for which numbers x is f of x equal to 0. So remember, f of x is a y value. Y is equal to 0. That means the height of the graph is 0. That's right here. And that happens at these 2 points here. Notice that's when those are the 2 points where the x or the y value is 0. And that's occurring when x is -2 and when x is 1. And so those are the two x values. Whoops. Where the height of the graph is 0 or the y value is 0. It says for which numbers x is f of x equal to 2. So now the y value is 2 or the height of the graph is 2. That happens here. And if you're looking on the graph, that's just happening at this one point here. And that's the point where the y value is 2 and the corresponding x value would be -3. And so -3 is our answer there. And just like the last graph we did, you don't have any kind of symmetry here, and so we would say it's not even or odd. Alright, on number 12, we're going to be using what we call the algebra test. So to determine if these functions are odd, even, or neither, we're going to plug in negative or minus x. So let's make a shell and let's replace x with minus x. And now let's see, the square root of minus x, think about this here. I said square root, I mean absolute value. The absolute value of a negative number is positive. The absolute value of a positive number is positive. Absolute value is defined as distance from 0 on the number line, and so it's always going to give us a positive answer. And so absolute value of minus x will equal the absolute value of x. As an example, the absolute value of negative 3 is equal to the absolute value of 3. They both equal 3. So this is true for any value. And so we can just replace the absolute value of minus x with the absolute value of x. And so notice this function doesn't change. And so this is an even function because we got the original function back. And if it's an even function, we know we have symmetry with respect to the y-axis. All right, let's look at problem B. Again, we'll do the same thing. We'll do the algebra test. Let's plug in minus x here. Well, minus x to the 4th power, that's going to be x to the 4th. And a minus x squared is going to be x squared, so we'll end up with plus 2x squared here. And let's go ahead and bring down the minus 8. And so again, we're equal to the original function. And so this is going to be an even function with y-axis symmetry. All right, let's go ahead and do part C. So there's our skeleton. Let's plug in minus x. We know that minus x cubed, when we multiply 3 minus x's, we're going to get a negative number, negative x cubed here. But notice you've got this negative out front, so it'll be negative x cubed. We're going to end up with a positive x cubed. And then 2 times a minus x is minus 2x. So notice what happened here. We had a minus x squared, now we have a positive x squared. We had a 2x, now we have a minus 2x. So each of our terms have changed signs. And so this is the case where this is an odd function, and that means we have origin symmetry. All right, let's look at D. We'll do the same thing. Let's plug in minus x. We're going to get x squared plus x plus 6. So notice the x squared term didn't change. The original function had a minus x, and now we have a positive x, so that one actually did. And then the plus 6 didn't change. The thing about it is we're either going to get the same function or each term is going to be the opposite. And so we don't have either of those cases here, so this is neither, which means we don't have any of these kinds of symmetry, origin or y-axis symmetry. All right, and let's do the same thing with the last problem here. We'll plug in minus x. You end up with minus x minus 1 over minus x minus 2. There's a lot of negative stuff going on there. We could actually do a little trick here and multiply the numerator and numerator and denominator by negative 1. And when you do that, you have to distribute the negative. You end up with x plus 1 over x plus 2. So notice the x's didn't change signs, but the minus 1 and the minus 2 became positive. And so this is another case where we have neither, and so we're going to have no symmetry. All right, let's look at 13. It says use the graph of f of x on the right as the parent graph. Describe how a point on the parent graph is transformed using translations and reflections, and then draw the graph of the function. So what we have here, first of all, because of the plus 1, we're going to move each point 1 left. Because of the minus 2, we're going to move the graph down 2. We know the minus 2 is totally separate from the x, and that's why we're going to do a vertical shift. The plus 1 is going to cause a horizontal shift, and those are the ones where you go the opposite instead of going plus 1 to the right, we actually go 1 to the left. So let's go ahead and move each point 1 left and down 2. So first of all, you need to identify some key points. That's these. So first of all, I'm going to look at this point here. If you look on the other side of the x-axis, you'll find a point the same distance away. Or wait, I'm sorry, I'm thinking of the wrong thing here. Hold on a second. Oh, so we're going to move each point one. So starting with this point here, we're going to move that point 1 to the left and down 2. So I'll do that with each point. And I'm still getting my lines in here that I don't want. Let's move, whoops. Hold on a second, there we go. Alright, so there's those 2 points have been moved down, or left 1 and down 2. Let's do the same thing with the other points. And you can kind of draw the lines as you go. And so that's the graph for part A. Now for part B, you got that minus out front. So that's going to cause a reflection through the y-axis. That's how we indicate that. And because of the plus 3, we're going to move up 3. And we'll get to that in a second. So we talked about how you should always do reflections first. And so let's go ahead and do that. We're going to reflect each point on the original graph, the one in black. So here's where we're going to actually go to the other side. For that point there, we're going to go to the other side down 4. And so that's going to be that point there. This point here, you got to go to the other side, and it's away 2 on the opposite side of y equals x. I'm sorry, of the x-axis there. And so that'll be that point there. Notice here we're going to cross to the other side, 1 away, and we're going to have that point. And then from there on, actually let's go ahead and draw the lines here. And then you'll have the graph go like that. So the green graph here is basically minus f of x. And so now here's where we're going to move everything up 3. So we're going to move, we reflected f through the x-axis already, and now we're moving each point up 3. So I'm going to take the green graph, and I'm going to move everything up 3. And that's your answer for part B. Now on number 14, I'm going to go ahead and rewrite this function. It says identify the parent function. Well, there's a square root here, so that's the square root function. Whoops, I messed that up. This should be square root. And so because of the minus out front, actually I graphed the parent there. Because of the minus out front, we're going to have a reflection through the x-axis. Because of the minus 2 underneath the radical there, we're going to have a horizontal shift. That's going to be right 2. So we know we want to reflect first, and again this is going to go across the x-axis. So notice this point here doesn't move because it's on the x-axis, but these here are reflected. And so this is y equals minus the square root of x. And then we just need to move everything right 2. And so the green graph is your final answer here. Let's move on to number 15. It says write the equation of the basic graph y equals x squared if it's transformed by shifting the graph, let's see, 4 units to the right, so right 4, reflected through the x-axis, so that's what we've had so far, and then shift 3 upward. So I'm going to go ahead and write y equals, now since there's a reflection that's through the x-axis, we'll need a minus out front, and then the function. Now notice, since we have a horizontal shift right 4, it's going to be x minus 4 inside the parentheses, and that's what's squared. And then the plus, or moving it up 3, we're going to just put a plus 3 there. Now it's not a bad idea, because usually students are better starting with this and going in the opposite direction. So we can check ourselves by looking at what we have here. Because of the minus out in front, we have the reflection through the x-axis. Because of the minus 4, we have a shift 4 to the right, which is what we needed. And because of the plus 3, we would move up 3. So everything looks good here. So on part B, it says write the equation for the following graphs using your knowledge of graphing techniques. The dotted line is the parent graph. Explain how you obtained your answer. So look at part B. I'm sorry, I didn't make that comment at the top there. I'm going to put that there. Part B, so y equals the absolute value of x. That's what that function is. Remember, the parent one is the dotted line there. And so notice we definitely have a reflection down. In fact, it would look like that. That's y equals minus the absolute value of x. And then you can see that the graph that we need to get has been shifted 2 to the left. And so we're going to have a horizontal shift left 2. So we have a reflection through the x-axis, and then we're going to shift left 2. So we're going to end up with y equals minus out front because of the reflection. And notice the x plus 2 inside, that's what's causing the shift 2 to the left. Alright, on number 2, now we're working with the what I call the ET function, or y equals square root of x. Of course, it goes like this. If we reflect it through the y-axis, notice it'll look like the shape that we're trying to get to here. So we do have a reflection through the y-axis, so we could write that as y equals the square root of minus x. And then notice that graph's just been moved down 3. So what we have is a reflection through the y-axis. So that's y equals square root of minus x. And then it's been moved down 3, so that's a vertical shift down 3. And so we'll write that using a minus 3. Alright, let's move on to number 16. So we're supposed to be finding domain here. So domain of f, we know that with radical functions and rational functions, we're going to have a restriction on our domain. So at square root of x plus 3, we want to set x plus 3 to be greater or equal to 0. And when we solve for x there, we get x is greater or equal to negative 3. So the domain is negative 3 to infinity. Now for g, we know that x can't be 1 because then our denominator would be 0 and the function would be undefined. So that's our only restricted value. Any other input can be plugged in. So the domain is everything except 1, and that's how we write that. And notice h of x is just a linear function. There are no restrictions there. The domain is all real numbers. Alright, so on D it says find the domain of g plus f, g minus f, and g times f. What we learned is if we just intersect the two domains of g and f, that'll give us our domain for each of these. What I like to use is the word, basically I look at what the two domains have in common. So the domain of g includes everything but 1. The domain of f is negative 3 to infinity. So what do these two domains have in common? Well, it doesn't hurt to draw the graph. That would be the domain of g, everything but 1, and then the domain of f, negative 3 and all the numbers greater than negative 3. What do these two sets have in common? Well, basically they have negative 3 to infinity in common. They both have at least negative 3 up to infinity. The only exception is this point right here. 1 is not in both of the sets, so you can't say that that's a number they have in common. So your answer is going to be negative 3 to infinity, but we have to take out 1. So that's how we would do that. Now for E, the domain will be the same. We're still working with G and F. The only thing is if F is 0, then we'd be undefined. So we want to set F equal to 0. That'd be the square root of x plus 3 equal to 0. Now this is going to be 0 whenever x is negative 3. And so that's my solution there. So that's another restricted value. X can't be negative 3 because then our denominator would be 0. So we're going to take the domain that we had for part D, and we just need to make sure negative 3 is not in there. Well, notice it currently is, so all we need to do is put a parenthesis by the negative 3, and now we're good. Alright, so let's look at F now. So the domain of F is negative 3 to infinity. The domain of H, I'm going to go ahead and graph that one. The domain of H is all real numbers. So what do these two sets have in common? Well, negative 3 to infinity is in both sets, so that's what they have in common. Now on part G, we're working with F and H. We need to exclude any values of x that cause h to be equal to 0. So I want to know when h of x is equal to 0. That means x minus 5, and we want to know when that's equal to 0. Well, if you solve there, you get x equals 5. So notice 5 cannot be, can't be part of our domain because it causes our denominator to be 0. So the set negative 3 to infinity includes 5. We've got to take it out. So that's going to be your final domain. Alright, and this is the end of the third video here.